the previous panel, I cited the example where you have, a 54 megabit per second potential on Wi-Fi today, and you've got a T1 connected to it. Now you look at LTE, and it's even worse, if you will. Theoretically, you have up to 150 megabits per second on a 20 megahertz LTE radio channel. If you look at the LTE advanced standard, it takes you to 1 gigabit per second. And so I guess the question is, how much backhaul capacity do you really need? Because on the one hand, you have the potential of 1 gigabit per second. On the other hand, you're dealing with a very small picocell. You're not going to have necessarily a lot of users on it at any one time. So do you really need a gigabit per second? Is that what the operators are asking for? Again, most applications don't use more than a few megabits or tens of megabits per second. So it's not like an individual user is going to get 1 gig per second because the internet won't support, it won't support it. So what do you look at in terms of, what are operators telling you in terms of, how much backhaul they really think they need, going to a picocell, giving all of those various things at play?
I think the assumption about how much bandwidth is needed has a lot to do with the approach you're taking to solve the problem. Of course, when you're talking about folks that are planning to use fiber, fiber has a gigabit with ease. So, you need a gigabit. You talk to the guys that do the non-line of sight kind of backhaul. They try to portray a relatively low requirements because they can do more than 100 or 200 megabits. We happen to be focused primarily on the very high frequencies where amount of spectrum available is in multiple gigahertz. So for us to do a gigabit per second is not much more difficult than to do 100 meg. So obviously we're trying to offer a gig capacity because we can. The question of how much you really need has a lot to do with the topology. If you're talking about, I have a single picocell and I'm trying to backhaul the traffic, probably 100 meg is, 150 meg is probably enough. But when you start to think about how these things are going to be deployed in urban areas, you think about putting them on light poles, utility poles, and you're probably going to daisy chain a few of them, or you're going to create a mesh. So very quickly, you get into portions of the network where a single link is actually carrying multiple cells. So talking about needing a gigabit, in my opinion, is not out of the question, but it's obviously not on day one. And it obviously depends on how many small cells you actually carry in this topology.
I think the other thing we think about is using small cells for coverage. I think, femtocells are definitely targeted in that space, and I live up in the Oakland Hills, and none of the operators really support anybody's needs there. So everybody has a femtocell, and they kind of love it. I guess my question for the panelists is, when you think about picocells, is there an opportunity for picocells also being used as a coverage play? Maybe not so much in dense urban areas, but putting a picocell in this room, putting picocells kind of in suburban rural areas, more as a coverage play than a capacity play. And then also keeping in mind you've got LTE going in at 700 megahertz, so you get this more favorable RF propagation as well going for you. Do you think there's going to be a coverage problem with next generation networks, and do picocells have an opportunity there to really solve some of those challenges and all?
So I'll take that one and start with it. I think in the right order, the answer is yes, 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 and yes. And keeping in mind here, we're pretty much in a 4-alarm fire drill here. As vendors, we're loving it, but at the same time, it's a big challenging environment. So any and all of these solutions will be used, but I don't see anyone deploying anything for coverage anymore without dramatic consideration for capacity. Being part of that, business case. Actually, in some of these cases now are coming last, which is great for vendors, but at the same time, it's just a, sort of a massive build out. And in this 4-alarm fire, fiber and cable companies are, have a dramatic capacity that they actually can show up with and, complement the mobile operators with. So I see all of these solutions being put in play. And one thing I also want to emphasize, which is what you said earlier, which is the aesthetics. I don't think I had a true appreciation for aesthetics and some of the flexibility in design solutions and devices, small cells, before coming to this company, Belair. it's true what you said. I mean, they want it to be this small, and they wanted, you know, if there are going to be antennas, you know, have them hidden someplace and so forth. So it's very much something that plays into it. So whether it's a Pico or a small cell LTE and Wi-Fi, you know, they just want it to be aesthetically pleasing, fit in, and if it can be as small as an iPhone, great.
Hi. Talk about backup power for just a second, and kind of a follow-up to that latest comment about using one cabinet to fit all the electronics. Is that how to best handle backup power and the needs to have backup power and yet not create too much clutter on the pole?
Mm-hmm. Yeah. That's a good question. I think a lot of these devices ultimately may be line powered versus having a standalone package at each site. There may be a small battery that's sitting there in reserve in case that line is interrupted somehow. But I think we have to consider where we have a string of small cell sites, say through a neighborhood or along a city street, that we're not going to be able to power them necessarily individually, unless you're on a power pole and somehow we can tap into that. But I think by and large we're looking at some kind of line powering arrangement to make that happen.